All right, let's start by talking about yesterday's homework. I hope you tried number 11. I'm going to emphasize number 11. I guarantee you those questions will show up again. On the other hand, number 12, you don't need to know how to do. This used to be in our curriculum, but we are no longer asked to do anything where the arrangements are in a circle. Okay, if you see a circle, that means you don't need to know how to do that one. Okay, very quickly, let me talk about how to do a circle. Okay, if you have, let's say, 5 objects and you're permuting them like this, it's 5 factorial. If you have 5 and it's in a circle, it's 5 minus 1 factorial. Okay, so in general, if you have n factorial for in a row, it's n minus 1 in a circle. Okay, so again, you don't need to know that, but that's how you do it. That actually will not give you the answer for number 12 because number 12, it's actually a circle, but it's also one that you can turn upside down. Okay, so something you can manipulate like a bracelet. For these, it's actually going to be n minus 1 factorial divided by 2. Okay, so that's how you would do number 12, but you don't need to know how to do it. Number 11, though, it asks you to rearrange or to find out how many arrangements you can make of some, I think it's video games, and there are certain types. So let's take a look at, and they have to stay together. So there's 4 of the first kind of games. So if you think about arranging them, it's 4 factorial. The next kind of game, it's also 4 factorial. The next kind, there's 2 games, we'll rearrange them, and then we'll rearrange those 5. These are 4 different groups, and we've rearranged every group. So, you can picture these games stacked here like this. If we switch the order, then, this book would all of a sudden, or game or whatever would be in front. So it's a different order. Okay? There's one more thing you need to do because these groups could be rearranged. Okay? If we take this group, this group, this group, and this group, that's 4 ways to rearrange those. So this question would be like this. You would multiply 4 factorial times 4 factorial times 2 factorial times 5 factorial, and then how many groups are there? There's 4, and we have to rearrange them. Okay, for sure that's going to show up again. Make sure you try those kind. All right. So we're just going to put a little bit of a condition on the permutation, and that's if there are identical objects. For example, if we rearrange the letters in Ella, here's 2 different arrangements. Okay, and now I'm going to switch the L's. Are those 2 different? Are those 2 different? Well, I switched the L's, but they're not different arrangements. Okay, so whenever we have identical objects, you're going to divide by whatever that identical object is factorial. Okay, so how would you do Ella? Well, if it's just 4 objects, you would go 4 factorial. But because there are 2 L's, we would go 2 factorial. Okay? So example number 2. I always laugh at this example. When we first made these notes, Mr. Favoni and I did them together, and this was one of his questions. This question, okay, I feel sorry for him in isolation right now, because if on his shelf he has 7 boxes of cereal and 5 of them are bran, that's sad. That's very sad. And to make things worse, look at what the other 2 are. Puffed wheat and granola. I'm telling you, I don't want to go to Favoni's house for breakfast. Like, there's no Fruit Loops, there's no Frosted Flakes, nothing tasty. It's crazy. Okay, so let's try the question. 7 boxes of cereal. So there would be 7 ways to rearrange them. But 5 are of the same kind. They're identical. A little glitch on the pen. So 5 identical objects. Now we can solve this by doing it this way. So there are 42 ways to rearrange those boxes. Okay, now this is a bit of a weird one. This one doesn't look like the same kind of question. Let me draw it out for you. Graham walks 8 blocks from his home to the library. He always walks east and south. East and south. So he's generally walking in this direction. So he lives here, okay, and he has to go 4 blocks south, and so this is south. He has to go 4 blocks that way, and he has to go 4 blocks east. Okay, this being like a block. This is 1 block, 2, 3, 4. Okay, so here's the library, here's where Graham is. How many ways can we get from Graham's place to the library? Well, here would be one way. You could go 4 south, 4 east, and that would be one way. You could go 4 east, 4 south, that would be another way. And then there's all these different ways we could go. There's many of them. All right, and we want to figure out how to do this without actually having to go through each one of the options. That is actually painful. Okay? So looking at it this way, if you're in applied, you'll actually go through some sort of pattern and try to figure out, how many ways can you get to here, and then how many ways can you get to here. And there is a way to do that, but I'm going to show you an easier way. What I know is that he has to go south 4 times, and he has to go east 4 times. He has to walk 8 blocks. So if you think of these as being letters, he has to walk 8 permute ways. Like it could go southeast, southeast, or south, southeast, east. Like there's many different ways. There are 8 factorial ways for him to travel. But 4 of them are identical. There's 4 times he travels south. And there's another 4 times that are identical when he travels east. Okay? So doing this, let's try to do this without a calculator. Now again, you'll get a calculator, but we might as well try to do it without one. So these 2 cancel. I can also cancel the 4 and the 2 because that equals 8. And if I divide 6 by 3, this becomes a 2. So now I have 7 times 5, which is 35, times 2, which is 70 ways. By the way, thinking back to the original method, can you imagine doing it this way, counting up to 70 that way? All the different ways you'd have to do? Pretty tough job. Okay, you'll see one like this for sure in your homework, and then you see this type. Okay, so he'll have, let's say he wants to go from here to the library here, and he has to go through, let's say there's a store here. So to do this, you would first figure out how many ways can I get to the store. So that would be what we just did there. 8 factorial, 4 factorial, 4 factorial. And then we would figure out how can I get from the store to the library. Well, in this case, we have to go south twice and east twice. So there's 4 factorial, and that's 2 factorial, 2 factorial. So you're going to have 70. And then this would be, I think, 6. So 70 ways to do this, and 6 ways to do this. What do we do when we have and? That's multiply. So there'd be 420 ways if you have a combination like that. Okay, don't forget, and means multiply, or means add. Okay? Alright. Next one. A kebab. 2 mushroom, 2 shrimp, 2 cherry tomatoes, 2 zucchini slices. There are 8 things to rearrange, but some of them are repeats. Okay? Now, these questions show up in many different ways. I remember a few years ago there was a question on the exam that said they're going to make a boat's going to make a signal using flags. They have 3 blue and 2 red. How many signals can they make? And people were very confused. But if you wrote it out like this, blue, 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 red, red, and you said, how many ways can I use those flags? It becomes a much easier question. Okay? Same here. There are how many letters? There are 11 letters. How many ways can we rearrange them? 11 factorial. There are 4 S's. There are 4 I's. And there are 2 P's. Okay, so that's how you would do that one. Again, you can use a calculator. You can try to simplify it. Doesn't matter. Identical question here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There are 13 numbers, but there are repeats. There are 2 1s. There are 3 2s. There are 2 4s. And there are 5 5s. Okay? So 1s, the 2s, the 4s, and the 5s. Okay? A few more examples like that. 1, 2, 3, 4, 5, 6. 6 factorial. There are 2 x's. Okay. Now let's do one that's a little bit more difficult. How many ways? And this is the one that I see so many times. Okay. There's this word together. It says how many ways can, okay, it's the same 6 variables, sorry, same 6 letters. How many ways can it be arranged if the vowels must be together? In other words, the A, the U, and the E have to be in a row. Now, it could be in a different arrangement, but they have to be in a row. I always think of this as, let's tie them together. Let's tie them together and make them one letter. Okay? So now we have X, X, Z, and we have this group of letters that we've tied together. It's just one item. So how would I rearrange these 4 things? 4 factorial. But wait, there are 2 X's. Is that it? Not quite. Because these 3 letters that we've tied together, we could rearrange them. How many ways can you rearrange 3 letters? 3 factorial. So this question would look like this. Okay, which I believe is 72. All right, this together. Go and find questions like that. Try them. Ask me if you get stuck, because for sure, you're going to see those. They're very common, and they're tricky. Every one is a little bit different. Please try them. All right, there's the homework for today.